Welcome back. This video is for learning target 1C starting on page 8, continuing on to page 9 for your practice. Go ahead and turn to page 8, please. Page 8, learning target is I can simplify square root expressions. Key word today is we're simplifying square root expressions today. This is very different from what we did a few days ago when we were estimating square roots. So we're not estimating today, we are simplifying. Okay, so you won't need a calculator because you're not punching in any square roots and finding out the square root of something. We're just simplifying today. Okay, 2 steps for you. How do you simplify square roots? First step, you need to find the biggest perfect square factor. Key word here is biggest perfect square. I made a nice cheat sheet for you over here so you don't have to memorize any of these. So you'll be using this cheat sheet here to find your perfect squares. Second step, then you're just going to simplify. Okay, you're going to take it down as far as you can, as simple as you can, most simplest form. So we're going to explore 2 different properties today. Our first property is called product property of radicals. Now radicals is just another way to say square root. So think of this as the product property of square roots. Okay, what the product property of radicals says is the square root of a times b is equivalent to taking the 2 numbers inside the square root and splitting them up, breaking them apart into 2 factors that equal a times b. So the square root of a times b is equal to the square root of a times the square root of b. Now the important part here that I want you to make sure you write down, this first broken square root that you split up into, this one has to be a perfect square. It has to come from your cheat sheet list, and it has to be the biggest one you can find. Okay? So we're going to write, how about biggest perfect square? Okay? So let's put these 2 steps into practice using our product property of radicals. Okay, our first example is the square root of 20. So what we're going to do here is we're going to break the square root of 20 into 2 separate square roots where the product still equals 20. Okay, remember I just talked about this. The first square root that you break it into has to come from the perfect square list here, and it has to be the biggest number you can find. So because we're working with square root of 20, I know that and again, we never use 1 here, so 1 we can just cross out, okay, because it doesn't do us any good to break it down to 1. We have 16 to choose from first. And why did I draw the line here? Because I know that 25 is too big. 25 won't go into 20. So what we're going to do here is we're just going to use process of elimination and go up the list because we're looking for the biggest. So does 16 go into 20? No. Okay, and how do I know this if you're really bad at division here? If I do 20 divided by 16, notice it doesn't equal another whole number. So let's try 9. Does 9 go into 20? No, it equals a decimal. So our only option left is 4, and 4 does go into 20, because if I do 20 divided by 4, it equals 5. So my 2 factors, my first one coming from our list, is the square root of 4, and then my other one's going to be 5, because 4 times 5 is 20. Okay? Second step, simplify. So this part should be the easy part. The square root of 4 equals 2, and the square root of 5, we can't break down, we don't know it unless we punch in our calculator, but we don't want any decimals. It's an irrational number, so we're going to keep the square root of 5 as is. And this is it. That is our most simplified form. Well, how do you check to know if you're correct or not? Well, if I type in the square root of 20, I'm going to get 4.47, so on, so on, so on, so on. It's an irrational number. Okay? If I type in also my answer, 2 times the square root of 5, it should equal the same decimal. So let's take a look. Does 2 times the square root of 5 does it equal the same decimal? There's my 4.47, so on, so on, so on, so on. It is equivalent. It's just in a more simplified form. Okay? Let's take a look at our next one, square root of 45. We're going to take square root of 45, and we're going to break it down into 2 separate square roots. I know that I'm not going to use any number past 36 because 49 does not go into 45. It's bigger than the 45, so let's go down the list here. 36 does not go into 45. 25 does not go into 45. Let's double check. 45 divided by 25. It's not a whole number. 16. 45 divided by 16 does not go into 45. 9. 45 divided by 9. It does. It equals 5. So I know my first square root here is going to again come from our perfect square list is 9. And the other factor that goes with it to equal 45 is 5. 9 times 5 is 45. Let's go ahead and simplify. The square root of 9 equals 3 times, and then the square root of 5 is already irrational. It can't be simplified, so we're going to keep the square root of 5. And this is our final simplified form. Let's double check that it's equivalent. The square root of 45. Whoops. Let's try that again. Square root of 45 equals 6.708. Let's try out our answer and see if it works. 3 times the square root of 5 also equals 6.708. So I know that these are equivalent. We are good. Okay, let's try the square root of 90. Square root of 90, let's break it up. I know the square root of 90, I'm not going to use any perfect square that's bigger than 81 because 100 will not go into 90. So let's try 81. I know 81 doesn't go into 90. Does 64. Let's try to look here. 90 divided by 64. No go. 49, I know it doesn't. 36, let's give it a try. 90 divided by 36. Nope. 25. 90 divided by 25. Nope. 16, 90 divided by 16. 90 divided by 16, sorry. Nope. 9. Well, I know 9 is going to go into it. 90 divided by 9, which is 10. So, the biggest square root, perfect square root that I could find was 9. And then the factor that matches with it to equal 90 is 10, because 9 times 10 is 90. Let's simplify. Square root of 9 is 3. Square root of 10 is irrational, so I can't break that down. We're going to keep it as is. Final answer, 3 times the square root of 10. And again, give it a check. They both should be equivalent to each other in a calculator. Okay, last one. This one's now just a little bit different here. And it's different because we have an extra number that's sitting on the outside. So how this is read is 5 times the square root of 18. Okay, we're going to follow all the same steps we just did. However, this times 5 at the end is just going to be incorporated at the end. So when I write this out, I'm going to write 5 times, and then it's the square root of 18 that's going to be broken up into 2 separate pieces. So 18, I have these numbers to choose from. Okay, well, I know 16 doesn't go into 18. However, I do know 9 goes into 18. 18 divided by 9 is 2. So my 2 factors I broke into the 18 into is square root of 9 times the square root of 2. Okay, let's go ahead and simplify. We're going to keep the 5 exactly the same here. The square root of 9 equals 3. The square root of 2 is irrational and can't break it down, so we're going to keep it as is. And our last step here, we can actually simplify this together. Let's put these together. This is 5 times 3. Everything is multiplication here. There's no pluses or minuses here. 5 times 3 is 15. And then we'll just keep the square root of 2. It's just going to come right down. And our final simplified answer is 15 times the square root of 2. And again, let's give this a shot and check to see if it actually works. 5 times the square root of 18 equals 21.21. So that's what the original problem equaled in decimal form. Let's check our answer of 15 times the square root of 2 and see if it also equals 21.21. 15 times the square root of 2 equals, notice it equals the same exact decimal. So we know we are good because they are equivalent. Okay, so that's the product property of radicals. And we're going to use this property on our next property here, so keep that in mind. If you have questions about it, please make sure you're asking. Okay, let's take a look here. Whoops. I'm going to drag this down so we have this in our view here. Our next property is the quotient property of radicals. Okay, so again, to remind you, this is just another way to say square roots. Now we're doing quotients, so you're going to notice quotient means divide the 4 problems we have below are fractions, because fractions means divide. Okay? This product says I can take the square root of a fraction, so square root of a over b, and just break it up into 2 separate square roots. Okay? So I have the square root of a on top in the fraction bar and the square root of b as the denominator. So you're just going to keep it as a fraction, but they just get broken up into 2 separate square roots. All right, first one, let's take a look. So we have the square root of 6 over 9. Let's just break it into 2 separate parts. So the top is going to be square root of 6, bottom is going to be square root of 9. And then what we're going to do is we're going to work the numerator separate from the denominator, and then at the end they get combined, okay? Let's do the bottom first, because that's the easiest. The square root of 9 is just 3. So now the bottom is simplified. Let's do square root of 6. Can the square root of 6 be broken up into 2 separate parts like we had just done from the property above? So I know that, and again, 1 doesn't ever work, so does 4 go into 6? No, it doesn't. So if it doesn't, that means there's no number in this list that will break 6 down. So in other words, 6 cannot be broken down to the square root of 6, so we have to leave it as is. And our final answer here is the square root of 6 over 3. The simplified form of square root of 6 over 9. And again, use a calculator and see if it works. They should both equal the same decimal. Okay, let's try the one next to it. Split it up. Square root of 75 on top. Square root of 100 on the bottom. Let's simplify. Let's do the bottom first because it's the easiest, because the square root of 100 just equals 10. Perfect. Top, square root of 75. Can the square root of 75 be broken into 2 separate square roots? Well, I know 75 cannot be any bigger than 64, so does 64 go into 75? No. Does 49 go into 75? No. Does 36? Let's double check. 75 divided by 36. Whoops, 75 divided by 36. I did type that in right. Nope. 25. 75 divided by 25. There's our biggest factor, 25 it looks like. So let's go ahead. First one is 25 times 3. 25 times 3 is 75. Okay, let's go ahead and simplify this. Bottom number is already a 10. It's already simplified. Top, the square root of 25 is simplified to 5. The square root of 3 cannot be simplified. It's already irrational. It's already broken down. So we're going to keep that number as is. Okay? So in other words, if you wrote this as your final answer, I would accept it. It's simplified. However, if you want to take this one step further, because you actually can reduce this a little bit more. So we're going to reduce this. What can be reduced? Well, 5 over 10 in a fraction can be reduced to 1 over 2. And then I'm just going to keep the square root of 3 part that I didn't touch here. And this right here would be your most simplified form that you can get, because all I did was take this and reduce the 5 over 10. Okay? That means the square root of 75 over 100 is equivalent to 1 times the square root of 3 over 2. Next one. Let's go ahead and split it up here. Okay? Top separate from the bottom. Let's do the top here. Square root of 7. Can the square root of 7 be broken up by any of these numbers in here? Well, the only option that we have is 4. I know 4 doesn't go into 7. So if there's no number from this perfect square list, I know the square root of 7 can't be simplified anymore. It is what it is. Square root of 7 stays on the top. Bottom here. Now this is going to bring us back to what we've been talking about for the last few days. When we have the square and the square root, when they appear together and in the same expression, what happens to them? Well, if they're inverse operations of each other, we know that inverse operations undo each other. They cancel each other out. So if these two appear together, we know they cancel each other out. So what's left over is just the x. Okay? So again, these two symbols here, these two operations, they are inverse operations of each other. They will cancel each other out. So final answer, square root of 7 over 6 is a simplified form from our original problem. Okay, last one. Let's give this a shot. Let's break it up like we've been doing here, like the property right here says. Let's do the top part first since we just did this. Remember, the square something and the square root, when they're put together, they cancel each other out. So what's left over is just the x. So this part simplifies to the x. 80, well, let's break down the square root of 80. So I know that 80, I need to pick numbers 64 or higher. So let's take a look. Does 64 go into 80? No, it does not. 80 divided by 64 doesn't come out to be a whole number. 49 I know doesn't go into 80. How about 36? 80 divided by 36. Nope. 25. 80 divided by 25. Nope. 16. 80 divided by 16. And there it is, 16 and 5. So let's go ahead. First square root here is 16, and then times the square root of 5 is equivalent to the square root of 80. I just, again, use the product rule. Okay, let's go ahead and simplify this then. Top number stays the x. Bottom number simplifies. The square root of 16 is 4 times. The square root of 5 is an irrational number. It cannot be broken down, so we're going to keep that. It looks like everything looks good. There's no reducing of any sort. And there's our final simplified form. All right. So there's no summary for this lesson, so I'm just going to actually quickly summarize by heading back up to the 2 steps. Okay. When we simplify square roots, keep in mind you're always looking for the biggest perfect square factor when you break up a square root. Okay, and that biggest square factor is usually always that first part of the broken up square root. And then the second one is the one that's paired with it that equals the number underneath. And then the simplifying part should be the easy part once you break it up. Okay. So make sure you ask any questions if you could not follow along. Your goal now is to continue on this page. The bottom 6 problems are your classwork problems. Be sure to check back on the teacher page for your answers. All right, good luck. Happy classwork doing. Bye.